Okay, welcome to day 8 of functions, converting parametric equations. Last class we talked about parametric equations where we have two equations, one for x, one for y, both being functions of the input t. And today what we're going to do, we're going to take these two. These are our two parametric equations. And what we're going to do today is called something eliminate the parameter. The parameter is the letter t. So what we want to do is substitute one equation into the other to get only one equation with x's and y's only. Remember, that's Cartesian. So we're going to go from this weird form of parametric having two equations, one for x, one for y, back down to one equation that only has x's and y's in it. So what do I need to do? I need to solve one equation for the letter t. And I started it. I divide by -2. I get t equals -1/2 x plus 1/2. Once I have this, I could put this in for the letter t. So when I go ahead and substitute it in, I get y equals 2 minus parentheses -1/2 x plus 1/2. Y equals 2 plus 1/2 x minus 1/2. And when I'm all said and done, I get y equals 1/2 x plus 3/2. This is a linear equation, and now I have an equation that is just a Cartesian equation, and I've eliminated the parameter, which was the letter t. The rest of these notes are just examples of eliminating the parameter. You notice I took my first equation, I solved it for t, and I'm going to take this result for t. I'm going to substitute it in. So y equals 5 plus -1/3 x plus 2/3. And finally get y equals -1/3 x plus 5 2/3, or 17/3. That is a line. Yes, please feel free to pause this video or stop it anytime you want to look at my examples. But like I said, I'm taking my first equation and solving it for t, and then I'm taking this result, plugging it in here. Y equals 9 minus 4 parentheses 1/2 x plus 3/2. And then I'm going to distribute a little bit. I get y equals 9 minus 2x minus 6. And finally get y equals -2x plus 3. Again, that is a linear equation. I've gone from the original that had two equations, one for x, one for y, down to one equation that only has x's and y's that is in my regular Cartesian rectangular form. Again, I'm taking my first equation, solving it for t, and I'm putting into the second equation. I get y equals the square root of x plus 1. There's really nothing more to do here. That's my new equation, and I don't know, it's just a square root type of graph. Okay, for number 5, as you can see, I have x equals the square root of t. To get rid of the square root of t, I square both sides. I can just get t equals x squared. I'm going to put this in here. I get y equals parentheses x squared squared minus 3, or y equals x to the 4th minus 3. Something to the 4th power is called a quartic. Basically, it's just a U-shaped graph. It kind of looks like a parabola. Okay, that's the first page of notes. On to page 2, just a couple more examples. We have x equals t squared. To get rid of t squared, I just square root both sides. So I get t equals the square root of x. And all I'm going to do is put this in for here. Now I could also call this t equals x to the 1/2. So I get y equals x to the 1/2 cubed minus 5x to the 1/2 plus 3, or y equals, multiply exponents, x to the 3/2 minus 5x to the 1/2 plus 3, or if you want, y equals x the square root of x cubed minus 5 square root of x plus 3, and I don't think there's any really special name for this type of graph. It's going to be a little bit different looking. And finally, my last example, x equals 0.5 times t. Well, I don't divide by 0.5. I'm going to multiply both sides by 2. I get t equals 2x. This is a really simple substitution. I put this in here, and I get y equals 2 parentheses 2x squared minus 3. Y equals 2 parentheses 4x squared when I distribute the squared minus 3. Y equals 8x squared minus 3 is my Cartesian equation. I eliminated the parameter t, and going back to your Algebra 1 days, is a quadratic, or what we know as the graph of a parabola. Okay, not too much today, but thank you for paying attention.